Right. This is a video about the MAT 2019 question 5. Now, this is an important video with regards to what I would consider the kind of questions that the new style MAT, so that at post 2024 could be, where you're sort of typing it up um, onto a onto a computer. Now, with these kind of questions where it's not something that you sort of deal with in an A level, this idea of partitioning a set of n elements, it's really important that you get a feel for what it means. So they've given us a demonstration of f5 comma 2, but you might want to just sort of say to yourself, well, what would f6 comma 3, what does that mean? Well, that's the number of ways of partitioning six elements into three different um, subsets. Now, we know that we have to have at least one element in each subset. So, if we've got to have three subsets, the only way to do that is to have three subsets with two elements in each. So, you'd have that, and that, and then you can start to think about how many ways you can do that, etc. So, or if we wanted f of 6 comma 4, sorry, that's supposed to be an f. If we wanted f of 6 comma 4, well, that means we want at least four subsets, and we want at least two elements in each. Well, you can see that that's not possible, because if you've got four subsets and two elements in each, you need at least eight elements. Actually, that then feeds into part one. But before you even start reading the questions, having a little play around with these is really, really useful generally. So you've just got to feel for what the question's on about. So we've just covered part one. N elements, one subset. Well, clearly there's only one way to organize n elements into one subset, and that's putting all the elements in a single set. So that's always going to be one, because we don't care about the order of the elements within the set. Now, this bit here, part three, is really the crux of the question. And where this is sort of very common is this idea of sort of iterative functions for combinations. So using the other functions or other combinations to help you with the next one. So what we're saying with this first bullet point is, if you've got 1 to n, and you're splitting that into, say, k subsets, so you split into k, then if you were looking to have 1 to n split into k, sorry, 1 to n plus 1 split into k, you could just think about, well, this extra element that you've got, because you're splitting these into the same number of sets, it could just go in any of the sets that you've got for the 1 to n. So what you're going to have there, is, if so let me check the notation. So we want f of n plus 1. So using this first bullet point here, we can say f of n plus 1 into k subsets. Well, that's going to give us k, because we can add this n plus 1 into any of the k subsets that we'd made for the 1 to n. So we've got k lots of f of n elements into k. So again, we've taken that n plus 1th element and we've placed it into one of the k subsets. Okay, so however many ways there were of making k subsets from n elements, there's k lots of that, just by considering this first bullet point. Now, the other way of making new subsets is take any allowable partition of 1 to n and add Oh, sorry, I've done them the wrong way round there, haven't I? This one I've just done here was bullet point 2. Sorry, I've pointed the wrong one. Now this one is saying, well, because each subset has to have at least 2 elements, let's call that one, we're saying that take the n plus 1th element and pair it with one of the other n elements. Okay? And then we have 1 to say n minus 1 elements to deal with, and we know they can be organized into n minus 1, and we only want to make k minus 1 subsets with these because our kth subset is the subset where we've paired the n plus 1th and another element. So we've picked n from the n elements, we've paired n plus 1th element with one of the n. So there's n ways to make that pairing, and then you've got this number of ways of pairing the remaining n minus 1 elements into k minus 1 subsets. And so in total, fn plus 1k is going to be n lots of fn minus 1, n minus 1, k minus 1, plus k f nk. Now, that's pretty hard. It's really worth making sure you're confident about how that's put together. They have given you the way to put the what's the word I'm looking for? The iterative formula together. They've sort of explained how to do that with these 2 bullet points. Then you've just got to do the algebra, which is obviously still very hard. Now, if we think about this for 7.3, it's worth noting we've got f2. So if we're trying to use some sort of iteration, we might as well start with f of 5.2 being 10. And then let's look at sort of this, and this. Now we want to get to f of 7.3. Well, using this formula, if 7 is n plus 1, we've got 6 lots of f of 5 and 3 is k, so 5, 2. Well, that's good because we've got that. We've got what 5, 2 is already. So let's just double check that. So f of n plus 1k equals n f of n minus 1. I always just double check everything I'm doing with these. So the 7 is n plus 1, the 3 is k. So yeah, that's fine. Plus, and now the k is 3. And then we've got f of 6, 3. Well, we don't know f of 6, 3, so I need to find f of 6, 3. So this I've got, this I need. So f of 6, 3. Well, that's going to be, so now 6 is n plus 1, so that's going to be 5f of 4, 2, plus k, which is 3f of 5, 3. Well, based on part 1, I'm just thinking logically we can't split 5 elements into 3 separate subsets if we got to have at least 2 elements in each subset because we'd need at least 6. So that's just 0. So 6, 6, 3 is 5 lots of 4, 2. I don't have 4, 2, but f of, so I'm going to need that as well. F of 4, 2, well, that is, so n plus 1 is now 4, so that's going to be 3 f of 2, 1, which is just 1. We already know that from part 2 that this is 1. and then plus k, which in this case is 2, f of 3, 2, and we know 3, 2 is 0 again. So, and that is going to be 3 times 1, so that's 3. So f of 4, 2 is 3. So f of 6, 3 is therefore 15. And 3 times f of 6, 3 is therefore 45. So this is 60 plus 45, which is 105. So you're just using that iteration that you've already made. Now, of course, if you haven't got the iteration, there's just no way you're going to be able to do part 4, really, unless you've got a colossal amount of time. Now, part 5 is actually less complicated, and you don't even need to use part 3 or 4 for part 5. Now, a good way to do part 5 is to think about fixing your n subsets. Now, they've been pretty kind here because they said you've got 2n elements and you've got n subsets, which means you have to have 2 elements in every set. There's no option, there's no alternative for that. So you've got subset 1 with 2 elements, subset 2 with 2 elements, subset 3 with 2 elements, all the way up to subset n with also 2 elements. So imagine they're sort of fixed and you're randomly assigning numbers to the subset. Well, you've got 2n choices for the first element of the first subset, 2n minus 1, 2n minus 2, 2n minus 3. So if you think about distributing those, there's 2n factorial ways of distributing those 2n numbers. But that will be if order matters. Now, every single one of these subsets we've double counted because we've considered the first choice and the second choice to be different if we switch them around. So we're going to have to divide by 2, divide by 2, divide by 2. We have to divide by 2 n times to account for the fact that we've double counted every single bracket. But what we've also double counted is the fact that the order of the brackets doesn't actually matter. So, for example, if we had the numbers, I don't know, 2 and 6 here, well, it wouldn't matter if they were actually in the first bracket or the second bracket or the last bracket. Now, there are n factorial ways of ordering these n brackets, so we also have to divide by n factorial. And that's it. You know, yeah, that's it. I don't think there's any nice way. I mean, they haven't asked me to simplify it, have they? Give it. Show that it is correct. So I think the show that in this is just explain really. That's absolutely fine. So a hard, tricky question, but an important one to really get your head around. So let me know if that's not been explained well enough.